In this video, we will introduce and discuss some interesting SQL functions that we can use to summarize data and make decisions based on values in tables. As you follow along, please start SSMS, connect to our classroom server, make sure the VPN is running if you are off campus, and use the credentials provided in Blackboard under Course Documents to connect to the database called Other Functions You Should Know 2060. Those credentials will not be given here for security reasons. As we go through these slides and look at these examples, be aware that these are not best practices. You will probably not be embedding case statements and roll-up statements and select statements and if statements into queries on a regular basis. We will probably do that a different way to allow scalability and maintainability of our work. I will touch on that later on another slide, but I want to emphasize now that we're demonstrating how these functions work and how to use them by writing simple select statements, but we probably wouldn't do it this way in the real world. The syntax would be the same, the application would be the same, but the implementation in a select statement would probably not be the same. The case function. Those of you who are Java or C# or C++ developers recognize that the case statement looks very much like a switch. The case statement came first chronologically. It was added to SQL long before Java and C# existed, and roughly in parallel to C++, but it does provide much of the same functionality. To use the case function, we will operate on a table called car. You can see that table in the database once you're connected through SSMS. The table is simple. It has a few rows of data. It has a few columns. What we're primarily interested in is making decisions based on price and mileage, and then eventually we will make some decisions and operations on the description as well. Here are two case examples. We should grab this code, take it over to SSMS, and paste it into a query window. And here it is. The first example extracts all the columns from the car table, hence the select star, and an additional ad hoc column using a case expression. The case expression looks at the mileage value in each row. If the mileage is less than 10, then the value no miles is generated in the mileage qualification field. Remember that these cases, these when clauses, are hierarchical. The first one that matches is the one that returns a value. The case then ends after the first match. If you look, for example, at the second row in the table, the mileage is nice and big. That mileage is certainly not going to match the first couple. But if you look at the first row in the table, the mileage is 0. That mileage matches all three of these cases. It matches less than 10, it matches less than 100, it matches less than 20,000. It does not return all three of those values. It does not return no miles and very low miles and low miles. It only returns the first one hierarchically that matches. Therefore, if the mileage is 0, it returns no miles, and then it immediately kicks out of the case. Hierarchical case matching. If none of the cases match, if none of the when clauses match, It returns the else case if there is one. In this case, that would be high miles because the mileage is greater than all of the other when clauses. The output of that select appears in the results window. You can see the extra column added on the right, mileage qualification, and you can see that they match. The next example looks at the price of each individual row. If the price is greater than 100,000, it returns very expensive. Greater than 50,000, expensive. Greater than 20,000, moderately expensive. Greater than 10,000, affordable. Otherwise, if it's not greater than 10,000, it returns cheap from the else clause. Again, hierarchical. A car that is greater than $100,000 will also be greater than $50,000, but since it hit the first match, it kicks out immediately and returns very expensive. Be careful how you stack your cases, because the first match that you get from top to bottom will be the value returned by that case. Here is a miniature version of case. We could actually write our cases with nested IIFs or if functions. But if we just have one individual when clause in a case, it's more convenient to just use this if function instead. In this case, in this situation, we're looking for cars with a description that contains the word green. You can see why the data looks kind of funny, because I needed a way to demonstrate an interesting use of the if function, so I built a description that looks a little bit strange. It's got the color, the model year, and the model all tucked into one text field, which is not a good design implementation at all, but it demonstrates how to use the function. Let's grab this code, take that back to SSMS, that runs. The result is a column called isGreen added to the results set. If the row being processed has the word green in the description, then char index will return a value greater than 0. The if statement looks at that return value from char index, and if it's greater than 0, it provides the word green, otherwise it provides an empty string. Here is the green, this is the true case of the if, and here is an empty string. This is the false case of the if, or the else, if you will. We could make this look a little bit better by possibly putting a space in there. Now it's a little easier to read because there's a space in the column name. Sometimes that's appropriate, but I will tell you, looking ahead, as you get more involved in database management and application generation, we generally don't put spaces in column headings because they generally are provided by an adjunct tool down the road, like a report generator or a web page. So the space is great if you like to use it to make your columns easier to read at this point in your career, but you probably won't down the road. The choose function lets you consider kind of an index, and then it uses that index into a list of strings, and then it returns a value based on that index. Here's an example from the book where we are making a decision based on terms ID. If terms ID is 1, the choose function returns 10 days. If terms ID is 2, the choose function returns 20 days. If terms ID is 3, and so on. And that column becomes a column called net due, which appears at the end of the results set. We ask for invoice number, invoice date, and invoice total. And then we ask for a adjunct column, an ad hoc column called net due. This is probably very bad. It's probably very bad because terms ID is a foreign key into the terms table, but here we are using it as an index into a list of strings. If terms ID changes because, for example, we delete one of the terms in the terms table and the foreign key values all get edited, we've got to come back and we've got to change this select statement. There's a huge exposure here to a big maintenance headache because terms ID has two purposes now. It has a purpose of being a foreign key into a terms table, and it has the purpose of being an index into this choose function. This is not in any way a best practice. It demonstrates how choose works. It does not demonstrate how we would do things to increase maintainability. We're just asking to introduce a bug that's going to appear 5 years down the road when someone changes the terms ID and it doesn't exist as an index into this list anymore. Coalesce is kind of neat if you find yourself having to deal with null values and those null values are showing up in reports, or they're causing you problems with syntax errors in some code that you've written. You can coalesce those nulls away. For this example, we'll be using the cat table. The cat table has a color. The color can be null. To be useful, coalesce needs to operate on an attribute or a column that could potentially be null. Therefore, we leave the box checked. Sometimes we do that. It's a design consideration. That decision is made long before we start creating tables. In the design phase of any project, we would have to decide and ask ourselves and find out from the domain experts what data fields can be null. In this case, we're saying that we can have a cat, but the cat may not have a color on file. Does that make sense? Well, every cat has fur, or even if it doesn't have fur, it has skin. And every cat has some color to it. Cats aren't transparent. But we could say for this particular case, whatever database we are creating here, whatever real-world scenario we are modeling, it is possible that we don't know the color of the cat. I'm not here to judge. Coalesce then looks at the color field. If the color is null, it returns unknown. Otherwise, it returns the value in the color field. Grab this code. In this case, I've listed in my results set the cat, the color of the cat as stored in the table, and a coalesce operator on the color of the cat. Now, I made this intentionally slightly obtuse. Notice that I have two columns with the same column heading. I did that just to show you that I can. Not a good idea again. Not something we would ever do because we would just be confusing the developers that came after us and wanted to make use of these queries. Remember that most of the time we're writing these queries for someone else to use. They're going into a repository, they're available to the developers of the project, and the last thing you want to do is have a developer knocking on your door and asking why you have two columns with the same name. Very confusing. I could rename this column to adjusted color. Now I've got a fighting chance of understanding the difference between the two columns. One is color, one is adjusted color. Or I could consider removing the original color column completely and then leaving the user of my query with only useful information. Again, this is going to be driven by the purpose, the intended use of this query. Are both color columns necessary, or is only the adjusted column the result of the coalesce necessary? I can't tell you the answer to that because I don't know what this query will be used for. It's completely out of context. We're just doing it as an example. The moral of the story then is to think very carefully about the purpose of the query as you write it and go from the design that you were given. In our next example, we will look at the purchase item table in the same database. The purchase item table is relatively simple. It has a purchase ID, which is a primary key. It has a supplier. It has a purchase type. It has a purchase amount, and it has the date of purchase. Again, not normalized to any great extent. Not something we would put into production. We would have supplier in a separate table with a foreign key, purchase type, separate table, foreign key. But for the purposes of demonstrating the next function, we can certainly use this data. The grouping function lets us create a summary row, and instead of having a null value in one of the text fields, we can put in some descriptive character value. Here's our first cut. I'm not going to run this for you, but if you study this closely, we're doing a group by, and inside the group by we're rolling up on purchase date, month, and purchase type, and then we're calculating the sum of the purchase amount. We can see that in April there were 4 purchase types: electrical, kitchenware, lighting, and then finally a monthly total, which isn't really a purchase type. But we have very nice rolled up sums for each of the months. Each month has a monthly total. So look at row 4, monthly total for April. Look at row 8, monthly total for February. Look at row 11, monthly total for January. We're getting where we want to be, but we're not there yet because the months are out of chronological order. We'd like to have January first and then February because that's the way people look at the data. The information's all there, it's just out of order. And then look at the very bottom of the results set. There's no month for the grand total. Inconveniently then, we end up with the word null in the month row, which is okay. It's not a showstopper. It's not horrible. It just could be better. So we tweaked our query significantly, and we added a case so that we can compute the month number, January being 1, February being 2, March being 3, and sort by the month number. Look at the results set. In row 2, there's the first row for January. It's electrical. The second row for January is hardware. Third row for January is monthly total. That looks pretty good, but you can see that it's gotten worse as far as where the grand total is, because now the grand total is at the top because of the way nulls are sorted. The null sorts to the very top of the results set, and that forced the grand total row to the top. So it's still not what we want. If this is something that we want to look perfectly correct, then we need to move the grand total row to the bottom. You can grab this code. This is just from the previous slide. you can see that it gave us what you saw on the slide. The grand total row is at the top, which is kind of a drag because we expect grand totals to be at the bottom. Everything else looks pretty good. It's sorted by the name of the month, because we actually didn't sort by the name of the month, we sorted by the month number. And if we were to deliver this to an end user, we would just hide the month number column and hide the grouped column to give the customer just what they want to see. Remember, this result set would almost never ever go directly to an end user. We would not put this on a web page without significant reformatting and hiding some columns. So as you create a query, you are free to add things to that query knowing that they will never make it to the end user. No one is going to deliver this to the man on the street, the woman using her cell phone, the guy wanting to place an order on the internet. We're going to hide columns that are not useful or informative to end users. We can tweak the thing a little more, but we still don't have the column or the row with the grand totals all the way at the bottom. Now, I played some games with this, and I encourage you to take some time to study this, because I forced in a grouping or a sort with all Z's, which will be the last letter in the alphabet, just to force it to be at the bottom. Now, I'm okay with this. I have no problem with this. I can make this work. Some people might say that it's a little clunky because we're using this string literal to force the result of a sort to go to the bottom. There probably are other ways to do it. There may even be more elegant ways, but this works, and I expect you to study it, and I expect you to understand why it works and what I'm doing. On the next slide, here's the code. Let's grab it. In the case, if I'm grouping by purchase type, then I'm going to select ZZZZZZZ as my type. Otherwise, I'm going to take purchase type. So that's going to force anything with ZZZZZZZ, I'm not reading all the Z's, to go to the bottom of the sort, because we're sorting in alphabetical order. Here's what I really want then. I'm just going to skip ahead and grab the code, because we should probably look at the code rather than spend more time staring at that screen. There's my ultimate result. I'm sorted by month. January, February, March in chronological order, and I've got my grand total at the bottom, and I'm very happy with that. The records only go through May, so there is no June, July, August, but I've got my monthly totals in the right place, I've got my grand total in the right place, and because I'm using this what might look like a weird grouping to force the grand total to the bottom, everything sorts the right way. So take some time to study this. I've got a choose in here, I've got a case in here, I've got a grouping in here, and make sure that you're okay with the syntax, and make sure that you can break this down into parts and understand everything that it's doing, because these are relatively complex SQL statements, and if you can get good at this, it will be beneficial to you in your job. The next function we'll talk about is rank. Sometimes it's useful to rank rows not just across the entire table, which is easy, but within groupings or partitions. So we can have SQL do that for us. For this example, we will use a table called tPurchaseItem, which we already saw. And we're going to answer the question within each supplier, rank purchases in descending order by purchase amount. So look at the results set. The supplier Craftsman has 2 purchases ranked number 1 and number 2 according to purchase amount. And these rankings would become useful in other queries, or other developers may use them in their work. So right now they're just numbers, and you might be thinking, well, so what? They're already sorted. But now that they're sorted, and now that each row in the sort has a rank, that may become useful to someone else in their work. You might have a problem putting this into context because it just looks like a number. Grab that code. Flip over to SSMS. Rank by supplier. Execute. There's our code. This is just what we saw on the slide. This is relatively simple. All we did was add a call to the rank function, defining a partition. So our partition is supplier, which if you want to think of it as a group by, it's very similar to that. And then inside each supplier, we're ordering by purchase amount. And then within each purchase amount, we're assigning it a rank. If a supplier only has 1 purchase amount, that purchase amount has a rank of 1. If a supplier has 2 purchase amounts, like Craftsman does, the ranks are 1 and 2. No big deal. Very simple. May have a use down the road when you need numeric values for rows according to rank. Here it is. We will stop here. In the next video, we will pick up where we left off, discuss more functions, and also talk about software engineering in the context of why are we doing this, where should we be doing this, and are we actually doing the right thing when we use these functions.